Welcome back to the Operating Systems Crashcast. I'm Victor, and joining me as always is the brilliant Sheila. Today, we're diving into an essential topic in process synchronization, Mutex locks.
That's right, Victor. Mutex locks are a fundamental concept in operating systems, and understanding them is crucial for anyone working with concurrent programming or studying for OS interviews.
Absolutely. Let's start with the basics. Sheila, could you give our listeners a quick definition of what a Mutex lock is?
Of course. A Mutex lock, short for mutual exclusion lock, is a synchronization primitive used to protect shared resources in a multi-threaded environment. It ensures that only one thread can access a critical section of code at a time, preventing race conditions and maintaining data integrity.
Great explanation. To help our listeners visualize this concept, imagine a single-occupancy bathroom in a busy office. The Mutex lock acts like the door lock. Only one person can use the bathroom at a time, preventing awkward situations and ensuring privacy.
That's a perfect analogy, Victor. Now, let's dive a bit deeper into how Mutex locks work. When a thread wants to enter a critical section protected by a Mutex, it attempts to acquire the lock. If the lock is available, the thread gets it and enters the critical section. If another thread already holds the lock, the requesting thread is blocked and waits until the lock becomes available.
Exactly. And once a thread is done with the critical section, it releases the lock, allowing other waiting threads to acquire it. This mechanism ensures mutual exclusion, which is crucial for maintaining consistency in shared data structures.
It's worth noting that Mutex locks are different from other synchronization primitives like semaphores. While a semaphore can allow multiple threads to access a resource simultaneously, a Mutex is strictly binary. It's either locked or unlocked.
That's an important distinction, Sheila. Now let's talk about some advantages of Mutex locks. They're relatively simple to understand and use, making them a popular choice for basic synchronization needs. They also provide a clear ownership model. The thread that acquires the lock is responsible for releasing it.
Absolutely, Victor. However, Mutex locks aren't without their drawbacks. One potential issue is priority inversion, where a low-priority thread holding a Mutex can prevent a high-priority thread from running. This can lead to unexpected delays and performance problems.
That's a great point, Sheila. Priority inversion is indeed a concern, especially in real-time systems. Some operating systems implement priority inheritance protocols to mitigate this issue, where a low-priority thread temporarily inherits the priority of the highest priority thread waiting for the lock.
Exactly. Now let's discuss some real-world applications of Mutex locks. They're extensively used in operating system kernels to protect shared data structures like process tables, file system metadata, and network buffers. Can you think of any other common use cases, Victor?
Certainly. Mutex locks are also widely used in application-level programming. For instance, in a multi-threaded web server, Mutex locks might be used to protect a shared connection pool or to ensure atomic updates to session data. Database systems also rely heavily on Mutex locks to maintain consistency during concurrent transactions.
Those are excellent examples, Victor. It's clear that Mutex locks play a crucial role in many aspects of modern computing. Now, for our listeners preparing for interviews, what would you say are the most important things to remember about Mutex locks?
Great question, Sheila. I'd say the key points to remember are: 1. Mutex locks ensure mutual exclusion in critical sections. 2. They have two states, locked and unlocked. 3. Only the thread that acquired the lock can release it. 4. They can lead to priority inversion in certain scenarios. 5. Proper use of Mutex locks is essential to prevent deadlocks and ensure efficient concurrency.
Excellent summary, Victor. I'd also add that it's important to understand the trade-offs between Mutex locks and other synchronization primitives. While Mutex locks are simple and effective for many scenarios, more complex situations might require other tools like read-write locks, condition variables, or even lock-free algorithms.
Absolutely, Sheila. The choice of synchronization mechanism can have a significant impact on the performance and correctness of concurrent systems. It's crucial for developers and system designers to understand these trade-offs.
Indeed, Victor. As we wrap up, I think it's worth mentioning that while Mutex locks are a fundamental concept, the field of concurrent programming is constantly evolving. New techniques and algorithms are being developed to address the challenges of modern multi-core and distributed systems.
That's a great point, Sheila. The principles we've discussed today form the foundation for understanding more advanced synchronization techniques. I encourage our listeners to keep exploring and learning about the latest developments in this exciting field.
Absolutely, Victor. And remember, listeners, understanding Mutex locks isn't just about passing interviews. It's about building robust, efficient, and correct concurrent systems.
Well said, Sheila. That brings us to the end of today's episode on Mutex Locks. Thanks for tuning in to the Operating Systems Crashcast. Until next time, keep your processes synchronized and your critical sections protected.